This time we are going to come up with an expression equivalent to the Laplace transform of e to the power of t. We also are going to use the same formula for the Laplace transform of any function of t here. With this, we can also use that for types of examples involving e to the power of t. But again, let's show that here. So the Laplace transform of e to the power of t, as this would be our f of t here, we'll have this equivalent. The integral of 0 to infinity, e to the power of negative st. Your f of t is e to the power of t and then dt. Now, look into this. We have expressions or exponentiations of the same base. Therefore, we can add the exponents. So it would be the integral of 0 to infinity of e to the power of negative st plus t. This is all the exponent dt. To be simplified, you can always look into this. The integral of 0 to... So this is e factoring t. You will have, okay, you're factoring t. You will have negative s plus 1 dt. Or, if you would like to, you can always also rearrange it because this is with respect to t. So you will have e to the power of negative s plus 1 t, then dt. Okay, now this is now can be integrated once we assume this is e to the power of u du. Okay, so that would mean your u is negative s plus 1 times t. And take note, we are integrated with respect to t, hence our s is an arbitrary constant. So this would become, the du is just negative s plus 1 itself. This should be added here so that we could construct with e to the power of u du. Okay, so this would become equal to the integral, okay, again, the integral of 0 to infinity. You will have e to the power of negative s plus 1 t. You're adding here a constant s plus 1. It's a constant, okay, because s is an arbitrary constant in terms of this dt, because we have here dt here. With this can now be integrated, but of course, always consider that once you have this, you're adding that constant, you also need to neutralize that here, negative s plus 1. Okay? So you will have that as part of your process, that when you multiply that, you can always return to your original form. So with all of this, okay, so this is equal to 1 over negative s plus 1. Okay, you have that. And then the integral of this is just times e to the power of negative s plus 1 t, as t is integrated from 0 to infinity. Okay? So, looking into this, we can now break this into two portions. You have 1 over s plus 1. And then you can also apply here the law of negative exponent. 1 over e to the power of... Oh, sorry for that. Since this is not... we can now let's express this first. So that we can apply the law of negative exponent. Let's express this entire exponent as negative. Okay? You can actually do it like this. 1 over negative s plus 1. Then your exponent, as you factor negative 1, e to the power of negative, so you're factoring negative 1, okay? So you will have here a negative s, sorry, that's positive s, sorry, s minus 1t. We're doing this so that we can apply the law of negative exponent, stating here that your entire exponent is negative. So we can do this next step, 1 over negative s plus 1. Or if you would like also this to be similar to this expression here, you can also do this. Okay? We can also factor negative 1 here at the denominator. So you have factoring negative, you have 1 over s minus 1 now. As you factor negative 1 here in your denominator. Okay? So it would be the same as that. The purpose of that later on is that you can, of course, look into possibility of cancellation and so on and so forth. So you have, I'm replacing the negative in between of s minus 1. Okay? Then, now this is expressed as negative exponent. You can always put it down. E to the power of positive now, s minus 1 t. Okay? 0 to infinity. Now let's break it into two portions. The first one is negative 1 over s minus 1 times 1 over e to the power of s minus 1 as t approaches infinity. Okay, so as t approaches infinity, okay, so I'm gonna place here infinity, or as t approaches infinity, that's actually equal to this expression will now be equal to as t approaches infinity. Sorry for that notation. Okay, let's write this carefully. This is actually, sorry for that. This is t, right? As t approaches infinity, the entire expression approaches to 0. Just for this. In short, if this is 0 times this, the first expression is 0. Okay? Because we don't want infinity to be included in our expression, so we're just looking into that. Then, for this form, so you have minus negative 1 over s minus 1, then 1 over e to the power of s minus 1 times your t, which is 0. With this, 0 minus, or now plus 1 over s minus 1 times 1 over e to the power of 0, which is just equal to 1. So in short, the final form for the Laplace transform of the given expression e to the power of t, okay, e to the power of t is just equal to 0 plus this, or in short, 1 over s minus 1. Okay, so it's 1 over s minus 1. So let's look into that, the general form, as we look into other forms as well, where there is a constant here, or there's a constant somewhere here. Okay, so this is now the Laplace transform of this given expression. It's 1 over s minus 1. Thank you very much for watching.